Welcome to another lesson of IB Physics at Edu Solutions Institute. Today's lesson will be continuing with motion and looking at projectile motion. Now, projectile motion is different from the kinematic motion that we did last week, where we focus only on moving in a horizontal, which is the X plane, or in a vertical, which is the Y plane. Projectile motion is objects that move both in the X and the Y planes. And hence, we have a different approach to answer these questions because they're going in both planes. Now, the path of a full projectile is in a parabolic path. Parabolic path means a curve that goes to a maximum and comes back down to that original horizontal level. So in this diagram, we have a ball, it's being kicked, it goes up to a maximum height, and then it comes back down to the ground level, that where it was kicked from. So therefore, this is a full projectile motion. Now, under a full projectile motion, there are things that we need to know. Here, where the maximum it goes, that is called the maximum height, which is, we can denote it as a h. Right? At this maximum height, we need to know things. But before we go to there, if we look at this object, when it was kicked at an initial velocity u. Alright? Now, this initial velocity, because it is at an angle to the horizontal, is comprised of two velocities. That is the uy velocity, the y plane, and as well as the ux, the x plane. So these two velocities is what the u represents, right? Now, when the object reaches different points going up this projectile motion, these values, the uy will now change, right? So it's no longer uy, it becomes vy, but this x, it remains the same. So that tells us at any point of a projectile, the x component of the velocity, it doesn't change because there is no acceleration on the object externally when the object is moving in the air. The only acceleration that objects have moving in the air is due to gravity, which is a vertical acting force. So hence, the y's will change. So going up, the y will be getting smaller and smaller, right? Until it reaches the maximum height where there is no y and all that velocity is just u. And then when it's coming back down, we now start having y, still have x. When it's going closer here, the y gets bigger, x is still the same value, right? Even when it's about to touch the ground, we still have x being the same, and we still have y, the maximum y there, right? So that's something to remember, that there is no acceleration in the x plane. In the y plane, the acceleration is gravity, which is negative 9.81. All right, so now we know that the maximum height is where the object goes the maximum vertically, and we can find that value by utilizing this simple equation here, which tells us it's the initial velocity squared times sine squared theta, which is the angle that it was kicked initially, over 2 times g. Right? Also, we could use other equation, which is, remember we had motion equation from last class that says S is equal to ut plus half at squared. So because we're looking at the y plane, because we need the y distance here, it is now y is equal, or you can use h, is equal to the uy times t plus half of g times t squared. Alright, so now we notice that it's no longer u, which is the initial, but it's the u in the y plane. right? And it's the time it would take to reach this point, right? Or we could use another equation, which is v squared equals u squared plus 2as. And again, we replace, this is vy squared equals to uy squared plus 2 times g times s, in this case would be y. And we know if it was here that we need to know the maximum height, this vy would be 0, because at the maximum height, there is no velocity in the y plane. So this would be 0, this would be the initial y, right? G would be negative 9.81, and the y would be the height in which we want to find. So in this case, we don't need time, right? Now, what else do we know? We can find the range, which is from the point it was kicked to where it came back to that same level, how far away those 2 points are. So this distance right here is called the range, r. And this is given by u squared sine 2 theta over g. Or simple one would be x, which would be r, is equal to the speed in the x-plane, which doesn't change, times the time it would take to move from here to here, right? And that leads us into the time for a full projectile is given by 2u sine theta over g. Now the 2 is there because if we take away the 2, we're given the time to reach the maximum height, which is half of the projectile. So we put the 2 to give us this half plus this half. So therefore, what that tells us is if you want to know what's the time it takes to reach a half projectile, you just use u sine theta over g. But it's for a full projectile, then you put the 2 to represent this half plus this half. So this is one way type of projectile, but this is not all the types of projectile motion that we can look at. Let's look at another type. So another type could be the object is being pushed off, let's say off a table, off a cliff, right? But it's being pushed off in a horizontal motion. So here we have the object, it's being pushed off horizontally. So you know it's going to travel this path till it hits the ground. Now, what do we know here? We know that the initial velocity that's being pushed off with is only ux. Only ux because there is no y initially. Now, after it starts to fall, then we start having y. And we still know that ux still doesn't change. Right? So the y changes, going to get bigger and bigger each time, but the x remains the same. So we know this, and we know the height that it's going to fall, which would be y. Right? Now, this type of question is a half of a projectile question, which means we can find this distance, which is the range in this case. You can call x. X is still ux times t. T would be the time it takes to do that motion, right? We can find y using the same equation, uy sine uyt plus half of gt squared. And we know this part would be 0 because there is no initial y. So therefore, this formula becomes y is equal to half gt squared. We can use that to find the time specifically, because most times they will give us the height of where it's coming from. Or if you have the time, you can find the height at which it was falling from. Right? So this is another type of projectile. You can call this a half projectile motion. And then the other type of projectile is given by same setup here. The only difference is that it is being thrown at a specific angle. So to the horizontal, this ball was kicked or thrown upwards at an angle theta, right? So we know it's going to go up, come back down to this level, but it's going to not stop there. It's going to come back right down there. All right. So what we see here is that this point right here is a full projectile, but there's an extension to that full projectile. So we can't use these equations because these equations will not give a true representation of anything that's happening here. So the first formula is x remains the same, right? So ux times t will give us x, and this t is the time it will take to do this entire motion. How can we find that time? We can use this equation, that's y is equal to uyt plus half gt squared. Now this y we're going to use negative, right? Now the negative because the object when displaced up came back to that level, a full displacement of 0. When it goes below that level, you're doing a negative displacement, and that negative displacement is the height at which it was thrown off from. So therefore, this distance coming down is a negative displacement. That's the importance of this negative here, right? The initial in the y plane, which would be this uy times the time, which is the time it takes to the entire journey, plus half g t squared. And remember, g is equal to negative 9.81, always in a projectile motion, right? What if we didn't want to use that? We wanted to use this equation, right? So in this equation, we can have a, which is g, is equal to vy minus uy over t, right? Or we could use v squared equals u squared plus 2as as well, or the v squared here would be v squared in the y minus u squared in the y plus 2as, and the s here would be the negative y, and this a would be g, right? Now the final thing that we need to know about projectile is there's always a question that asks us, what's the velocity at the point just before it hits the ground, which is right here. Now, to note, we always do two things before we can find that velocity. The first thing is we always need to know what's the x at that point, which is the same as the x at the starting point. But importantly, we need to know the vy at that specific point, which we can use this formula, or we can use this formula to find the vy. Now, when we have both the x and the y, your velocity that is going to hit the ground with, which would be the resultant between those, which would be Pythagoras theorem that says ux squared plus vy squared. So we always, at that point, find the ux, the vy, and then we use Pythagoras theorem to give us what's the velocity at that specific point of contact with the ground. So that is it for today's lesson. I hope you have learned a lot about projectile motion. Look forward to do some calculations with you to show you how these formulas can be put into place. So that's it for this week, and see you guys next week where we continue with the IB syllabus. Thank you. See you soon.